so last class we stopped at testing and organization, and the reason you need to know about testing and organization is when you go and try to purchase a window, you want to see who certified and what the certification means. And again, windows cost a lot of money, so make sure you pick the right window and the right U factor. So first one is the National Fenestration Rating Council, NFRC. And they do the U factor calculation. The U factor is more involved than you think. It's not just a number that they put there. It requires a lot of testing and a lot of scientists that have to go behind the scenes and do all the calculation for the U factor. So it's very, very involved, even though it seems like it's a simple number. It took them a lot of science behind it to estimate that U factor, and also a lot of experimentation and testing. Did you guys ever hear about, for example, the car drag coefficient? Anybody watch any shows like car drivers and Top Gears? They always talk about the drag factor. And if you ever go to the factory and watch some of the documentaries about how they make cars, you know that they put the car in a wind tunnel and they put some smoke running through it so they can see the flow of the air. So this is a lot of experimentation. You can't just have the drag factor just based on simple calculations. So there's some kind of testing standards, and also calculation. If you look at the window, since we thought about testing, and I gave the example of the car. If the car is tested in a wind tunnel, probably they have to tell you what is the speed. At what speed you're going to have this drag. And if you notice, if you drive in a very windy day, probably you have lower gas mileage, especially if you have one of those MPG in your car. You notice the MPG goes lower a little bit. If it's very windy, if you're driving against the wind, or if you drive faster than the design speed. Most cars were designed to run between optimally on the highway, plus or minus the speed limit, so between 55 and 75, they get the best car mileage. And of course, it depends on the car itself. But every car manufacturer will tell you this is the optimum design. If you want to get the best mileage, you should go within this speed. So they put down the U factor calculation. The American Society for Heating and Refrigeration and Air Conditioning, ASHRAE, they set a lot of standards on what do we think is acceptable in terms of the CFM numbers, limitations, wind speed, and what is the, of course they collect a lot of data. For example, they say in the northeastern region, this is the data for the last 10 years, we're going to design for this data, and we might change it in 10 years. So a lot of people sit around, analyze the data, and change the standards. And they do also provide the theoretical framework for calculation for heat flows through the window, and what is deemed acceptable and whatnot, so the consumer will have something to base their spending on. And again, they provide the standards for the windows in terms of heat loss and heat gain. The aesthetics of the window is something that's up to you. You might be spending more money on the aesthetics than the function. They are concerned more with the function and safety of the window. Again, if you think about the window, it's very thin panel, and sometimes it gets subjected to a lot of wind. And we say that in Florida or some places that are subjected to hurricanes, you are required to have shutters. Lawrence Berkeley Laboratories, I think they're in upstate New York, they do simulation and development of new windows. So let's say somebody came with a new idea for a window. This is a lot that they do it, and they have the standards from either NFRC or ASHRAE. The American Society for Testing and Material, ASTM, probably you see the stamp all the time on boilers, ACs, and any metallurgic equipment. They basically put the standard for this material and see if it's suitable for this operation or not. That's why when you see a cracked boiler, you're not allowed to fix it or modify any design, because again, a lot of people spend a lot of time doing this design and also design what is called the safety factor. What is the safety factor? It's an engineering term, but I want you to be aware of it. For example, let's think of a bridge. The bridge has been designed by architects and civil engineers. They do the calculation and determine that this bridge will crash at 100,000 pounds. So they limit the weight on that bridge by a safety factor of 2, which means they will put the limit is at 500. So there is a safety factor. So we have to double the maximum amount to be able to break that bridge. Of course, bridges has a safety factor sometimes of 8, 8 safety factors, not even just 2. So you gotta understand how it works. If you go in elevators, you see the maximum weight, and there's an alarm for the maximum weight, but the elevator can take at least 8 times that weight until it breaks. So
Really?
they have to.
That's pretty crazy.
So they lie.
Yeah. Huh?
So they lie.
No, they consider always safety. So if you reach that point, it will break for sure. 100% it will break. So I don't want to be in the 100%. You want to be in the 100%? No. So if it says like 1,000 pounds, 1,000 pounds probably it will need you like 8 times that weight to break it for sure. So at 500, if you increase, they're more closer to the point where you might break. So they want to, and also you gotta understand, every time you reach the maximum, you're actually pushing the limit a little bit, you're stretching a little bit more. So be aware of these limitations. Also when you drive, think again, when you drive fast, your car has not been designed for this maneuvering and this speed and this gyration. If you want to drive really fast, you gotta have some performance car. We were talking yesterday about somebody who changes their rotors and brakes every 6 months. And if you see the way they drive, you understand why. The car has not been designed for like abrupt braking all the time. And if you go to any mechanic and ask them what happened, yeah, you probably hit the brake really hard all the time, so the rotors get overheated and they warp. So be aware of the design limitation, and there's design limitation put for everything for a reason. It's for your safety. Again, if you, for example, if you want to buy a performance car, like an M3, 911 Porsche, these cars at least like 150, 160,000. They put a lot of thousand to it so it can take that performance. So the same thing with windows here. If you talk about windows, the performance is a limitation of wind. If you exceed this wind, if you have particles being thrown at the window, it's not going to take it. It's designed to just resist the wind. Particles, leaves to be thrown out, it probably wasn't designed for that. It might take it for a limit, but it will break. So reading the label, guys. Reading the label. This is a common label you'll see if you go to Home Depot trying to buy a window or Lowe's. You'll see one of those labels. This is from the World Best Window. I spoke this company, of course, but they just want to tell you what is the material. So this is vinyl, clad wood frame, double glaze. So we have double glass. It's filled with argon gas, and it has low emissivity, which means not a lot of sunlight, not a lot of infrared will go through it. And argon fill is very good gas to insulate the window. And if it leaks, that means you lost your conductivity. This is the certification. And let's look here. I think this is, we agree that this is residential and non-residential, depending on how much people are living in the place. So the U factor is 0.32. Solar heat gain coefficient is 0.45, which means out of the 100% of the heat gain, you're gonna pass through 45%, which is good, but not that good. Visible transmission, 0.6, so almost 60% of the visible light is going to come in. And this is the air leakage. You can use that factor for infiltration. And the air leakage is given by CFM. And same numbers here for non-residential. Does these terms make sense to you? I mean, do you understand what they mean if you see it?
What's resident?
Residential and non-residential. And the reason being is the amount of temperature you'll have in the house, and the filtration is completely different between the two. Again, what goes into the U factor, and why is the U factor a big deal? Again, U factor is 1 over the resistance. It's calculated between a combination of all these 3 things. That's why it's a very difficult thing to calculate. Think of how much you have all the 4 modes of heat transfer. We have air leakage, that's infiltration. We have convection, natural convection. we have conduction through the pane, and we have also radiation. So you combine all these together and you come with one number, because you should appreciate this number. Some people spend like years and doing calculations to get these kind of numbers in theory. There's a lot of masters and PhD done only in calculating the U factors for some material. And you will think, why is that important? It is important because before you build a thing, window is easy to build. If you're going to build an aircraft or something really big, it's easier to have a number that will help you do the calculation in paper, which is much cheaper than to do it in real life and find out it's not really working. Heat gain through insulated glass, same idea. So if you look here, this is a solar heat gain. It's hitting the glass, some of it gets reflected by the glass, but a lot of it go in. So we reflect some of the radiation, but not all of it. A lot of convection comes through the crack, and some heat gets absorbed by the glass and goes through the pane, and eventually will transfer. And we have, if this is filled with argon gas or vacuum, I don't think they have vacuum anymore. What do they have vacuum?
That's easy.
Yes. You want to have vacuum. You want to have filled with something with the same pressure as the outside, not even pressurized. And I think at some point they had to try to do the vacuum pans, and it did not work. They just cracked easily. Glass can be very, very strong. So it's thin glass, even though it's filled with gas, you can still have some transmission, solar transmission coming in. And again, the pane itself radiates back to the room, and we have convection going on around it. The hot air will rise, as you can see, and goes out and circulate through the room, and you heat the room also through the radiation, and you also heat the walls with the fans. So you probably can see how putting your walls in the south and west side of your house is where you get all the heat. So if you're in the northern hemisphere, the sun is always going to be shining in the south side. Do you agree on that? You understand why? So we are tilted a little bit to the 20 degrees, the north. So the sun is always going to be shining in the south side, whether in the summer and in the winter. In the winter time, the sun is more likely to hit your house more in the west side than the east side. So you're better off putting your windows in the south and the west, because you're going to put it in the west to heat your house in the winter time when you need the heat from the sun.
That's the reason for daylight savings, isn't it?
Huh?
That's the reason for daylight savings, isn't it? The sun.
Not really. Daylight saving is just to conserve the hours, and I think it's daylight saving was put for the farmers,
Oh, okay.
so they can, because they used to work in the daylight. And there's one state that does not use daylight saving.
Arizona?
Yeah.
Arizona,
Yeah. Good for them, because it's really confusing. I don't like it. Solar optical characteristics. So, solar heat gain accounts for 40% of the total heat gain in the house. And if you live in a house with a lot of windows, probably you'll understand how much heat goes through the windows and how hot it can be. Lived in a house that was 2 stories. The first floor had a lot of windows, and even in the winter time, as soon as the sun rises, the whole entire floor is heated. In the summertime, it was so hot that I have to vent the house from the top, and it was really impossible to cool the house. So having windows is beautiful, it's nice, it's good aesthetically, but it works against you. When it comes in the summertime and you don't have enough shade. And some windows are really hard to put curtains on. You have the circular ones and triangular ones and so many windows. It's just very inconvenient. Yeah, so it's very, very inconvenient. You're better off using tint and films from the outside and window treatment. Solar heat gain coefficient is how much you're going to get out of the infrared coming through these windows. And again, luckily, remember this, you can always put some film, like a tint on the glass to block all the infrared. Shading coefficient, that's for the visible light. You want the least shading coefficient because you want the visible light. That's why you put the window in the first place. This graph shows the difference between glasses, between panes. So if you look here, these are remember when I showed you the whole spectrum of waves microwave and X-rays and all these things. Remember that? Vaguely, infrared, visible light, and ultraviolet. So this is our solar heat. So this is infrared, and you can see it's very large wavelength, micro and very small. Then you get your visible light, then your infrared. So anything below visible light is heat. And if you look at clear glass, it will let a lot of most of the visible light and also most of the heat. That's just regular clear glass that's doing nothing for you. The tinted bronze, you know those big buildings in downtown where they have the glass where they can see you but you cannot see them? Yeah. It's kind of one of those types. So it's tinted, it reflects some of the stuff. So you get some visible light from the inside, and it blocks also solar heat here. To an extent, but not a lot. But it blocks a lot of visible light. Reflective bronze goes again, another type with a lot of spray from the outside, and it blocks a lot of the visible light. It blocks some of the solar heat, but not a lot. So the best thing we have is the low E. The low E is, allows a lot of the visible light and prevent the heat to come in. And that didn't come up until the late 90s. I think what they use, I think it's some kind of particle of metal. Question.
Do they have like windows that are tinted during the summertime and then during the winter they become clear?
I wish. You know those glasses that you have,
Yeah, like
prescription
transition,
glasses?
yeah.
Transition?
Huh? Why can't they have like sunglasses like that? I've been looking for that for a while.
For what?
Like regular sunglasses that changes with sunlight.
Transition?
Yeah.
Connor has them.
Yeah, but why don't they sell like sunglasses, non-prescription that tint with
Oh, the
I mean, the doctors will change with
I think you gotta pay
Oh,
for
so
that.
like
that.
I think you can do it, but you gotta pay for it.
yeah, it's expensive.
Yes.
Oh.
I think it's the price. Or maybe they do have that, but I've never seen that in. I thought about it.
I think you gotta ask for it.
Whatever you want.
Huh?
DJs will make you whatever you want.
Okay.
Yeah, I think you gotta ask.
How come they don't have it for cars as well?
I know, right?
Good question.
Well, police don't like tinted windows in the first place.
Huh?
Police don't like tinted windows in the first place.
But if in the windshield.
It scratches.
No,
easy
you
to
can't
do
do that.
whatever
You
it
can't.
is.
No, what if it's like automatically tinted? If it's sunny, it will tint, and
You can't
Yeah,
like,
Well,
dark.
yeah, then, yeah.
Don't
then
allow
you
it.
could
Kids
just-
the very top of
That would be nice though, that would be dope.
It would be nice.
good idea though. Probably there's some laws or something about it.
Yeah.
So if tinting is illegal, how come it's everywhere? Everybody's tinting their cars.
You can't tint your windshield. It depends, because some manufacturers that use like paint.
Not the front and the side, driver's
No,
side.
it's regulated to a certain extent.
Exactly. Guys, let's finish this. We're gonna finish this week. Air leakage. So, passing air through the window is less of an issue in your windows because they have a lot of silicon and felt around it. Leak tested at pressure of 25 miles per hour according to Aston. So most windows look at the wind factor. And what is the wind in Springfield, the average wind? It's less than 20 miles per hour on average. So it shouldn't be a problem. New windows have an air leakage of 0.1 to 0.5 cubic foot per minute. That's not a lot. That's if it's a new window. Over time, you have to, I think within 5 years, you have to change some of the molding. And depending on how much you open it and close it, some of the mechanical linkage can leak some air. Most infiltration is between the window frame and the roof opening. So the window can be very sealed, very tight. However, what is the roof opening? Guys, the roof opening is the cut in the wall and the window frame. So a lot of the time this area is neglected and the window expand and contract more than, especially if it's aluminum, more than the wood. So probably over time, whatever you put in there, gypsum, silicon, caulk, it will get loose. This will get most of the leaks. Everybody got that?
No.
Okay, write it down. It's very important, especially this part here, because a lot of people neglect this part. They look at the window, it's solid. They don't look at the frame and the siding and the roof opening, where we have a lot of.
Which one's important?
Huh?
What's important?
All of it.
Think about retesting.
Okay.
found out about that, when I was cleaning the windows at my house with the power wash.
Yeah.
I got too close, I'm like, what the hell?
It's leaking, right? Yeah.
No, I seen the strip coming out. I never
Oh.
knew that the strip go around the windows. That's how.
Yeah.
So now I
I
gotta do
thought
it
you
before the
broke the
window.
window. Desire, no phones. No phones, please. Phones off, no phones. You got it. All right. Moving on. Again, the PowerPoint is completely on Blackboard. Resistance to condensation. This is a winter problem. It's very important because we pay for our window, for the view, for the function, and in the winter you find the whole thing is foggy. You cannot see through it. It's annoying. It will drip on your floor, on your frame, and it will slowly deteriorate your window. So why does it happen? What does condensation happen?
The heat on the inside and the cold on the outside.
Yeah, what else? What is condensation related to?
Water.
Water, humidity, relative humidity. What is the humidity in the winter that we keep the house at? Usually in the winter it's less humid. 40, you want to be at 40, right? So you want the humidity to be at 40, and if it increases, probably you're gonna have some condensation. The windows are going to be colder, right? So you have something to condensate the moisture on. In your car in the winter, if you're sitting inside the car, if it's warm, probably you're gonna fog the windows. If you have 4 people there breathing a lot of moisture, you have to heat the car until the car is heated enough. It's not going to be, it's going to be foggy a lot. Especially if the car that's wet and has a lot of moisture, you didn't make it very wet, it will leak. So it can lead to the deterioration of the window on opening. Most of the windows have mechanical linkage in it, so probably over time that will be an issue. It's a winter problem. The NFRC rate the windows condensation scale from 1 to 100. If we just think about it roughly now, what do you think will, if the window gets cold and inside it's moisture, what is the best ways? What can we do to solve this problem? Huh? Yeah? We can ventilate. What else? So we have humidity, we have a window that's cold. No, how can we fix the problem?
How can you fix it?
Yeah.
Well, balancing the
Huh?
temperature.
Remove the humidity.
Remove the humidity, that's one. Second thing,
Balancing the temperature.
what are you gonna do? This is what you can do with the air, over the window.
Pull the shade so you can't see it.
That goes with that, no window.
Yeah, open windows.
So either you remove the humidity or get a window that does not get cold. So in your car, when the car, again in the winter, when it's raining, like yesterday, it's foggy, what are you gonna do? You're gonna put the defrost. What does it do? First thing it does. It's from the inside.
Yeah, I
Goes
that
back.
It turns on your air compressor.
Any windows fog.
Not gonna do that. But you don't have ratings. You don't have ratings, okay? You don't have ratings. You put all the defrost in the car. What does it do first? Yeah. So you know, if it does cold, it's gonna kick on the compressor. Why? Because there are 2 ways to remove heat. Either you heat the air, or you remove it by condensation. So the air, first of all, to open the vent out, so it will absorb all the moisture from the inside and take it to the outside. After the car is warm enough, it will switch to hot air. Once you warm the car and the windows are hot, they're not gonna have condensation. So the same thing we can do here. Either we remove the moisture from the air, put a dehumidifier, or get a window that has higher U factor. So let's say the other window that we saw before, which has a U factor of 0.33. If the temperature outside is 0, do you know something about the dew temperature? Dew temperature. Dew point.
When it's gonna condensate.
It's the temperature where the water starts to condensate and at certain pressure. So let's say it's 0, and we go up. This is my window. So if I have humidity between 45%, I'm gonna have condensation. This is the condensation line. So either, I can't control the outside temperature. I can do only two things, either go to a higher insulation window, change the fan, or put a humidifier and go back to 40. 5% is not bad. And people don't understand that the humidifier is an air conditioner. It's an AC. So it's gonna run you it costs money to run that 24/7 to remove humidity. So you gotta go and find out where's the humidity coming from. Why is it humid? Check that out. If you have a lot of plants in your house, it's going to be humid. Few fish tanks here and there, it's going to be humid. I saw somebody actually where they had plants and they went on and covered all the pots with cellophane to reduce the evaporation. So you can find out what are the humidity sources. Window structure, we use frame, sash material, aluminum, wood, vinyl, fiberglass, and steel. These are the most common ones. There are some new ones, but these are the most common ones. Vinyl and UV. So we said vinyl is very great, but it's had the issues with the UV. But now there are some vinyl with built-in UV protection, so it can work very well, especially in certain places. Aluminum has very high U factor. So this is the problem with the aluminum. It conducts heat very fast. It's going to leak your heat to the outside. Mechanical operation. Again, that is the area of invention. You see windows open to the outside, they open to the inside, they slide up, they slide down, some of them don't open at all. Jealousy windows, that all blinds, and have a glass, and then this is closed. We looked at those up last class, did we? Jealousy windows? We did?
No.
I'll do it at the end of the class. It looks exactly like blinds, but made out of pieces of glass, and they close onto each other. Single pane.
Oh, I think I know what you're talking about.
Let me look up jealousy windows. It's very interesting.
Steel frame window, it's gotta be heavy.
Oh, yeah, put that.
That's what they look like.
Yeah, that's weird.
I think it makes your neighbor jealous.
Looks really weird.
They've been making them for years.
They have them a lot in the Cape,
Yeah.
in sunrooms. They're very impractical,
Look pretty
but some of them seal very well, like these ones.
Yeah, they're a little pain in the ass to clean.
I would think so, one by one.
Yeah, that's straight one, straight to that.
Oh yeah, strike one.
That's not living, really a swear.
Well, that's
It's a donkey.
Okay, so frame material, vinyl UV,
You're laughing.
and higher value, mechanical operation. So if you can't put a window that does not open and close, you save a lot of money. But again, you want some windows that will give you some ventilation. So there are three ways to improve the glass R value. Resistance to heat. Either we add some heat. So far we have 1, 2, and 3. Or you can make the glass thicker. Or you can change the gas filling. A lot of gases, a lot of it is filled with carbon. Special coating. That's what you can put from the outside to reflect the lights and the infrared. You can fill the glass with carbon dioxide, argon gas. They have higher value and they also
How do you do that?
good way. They do it at the manufacturer. And if you look inside the double pane, you see like a little rubber piece, and it's sealed. They vacuum, they fill it, they vacuum it, they fill it, then they seal the glass. So that's one reason also you want to that's one reason also you want to be careful when you slam your windows up and down. You might like crack one of those pieces and start to leak slowly. And as you said, it's heavier gas. Argon and carbon are much heavier than air, so it will leak slowly. If you see condensation inside your pane, you know that the window has leaked. You can have it repaired.
Yeah, I tell my wife to stop doing that.
Yeah, the slamming the window is not very good, especially if you have double pane. It's gonna cost you a lot of money to take the pane out and refill it. I don't think so. I Can't imagine how they clean from the inside if you have condensation and dirt. Yeah, that's really sad. So we can also improve the glass spacers between each panes. Those also a big area of heat. If we go with the camera and take a picture of the thermal picture of the house, you'll see a lot of the infrared going on. Windows films. This is another cheap way to improve the window heat loss through the glass, and also if you can put the plastic to insulate the entire window for the window. And it doesn't look that bad. Like I've seen some commercial where you put the plastic and you heat it and it becomes very tight. It looks okay. I mean, it's not that. Yeah. Especially in January, which is the coldest month. January and February is very cold, so it will save you some money, I guess, and good for the environment. Shades, lines, and shutters. These are very, very effective, even in the winter time. So during the night, even though there is no sun, it's good to put your shades on because again, it will improve the heat loss through the window. Blinds do the same thing. What we're doing, even though they have a lot of openings, you are slowing down the convection, the natural convection near the window. Shutters, the best solution to transfer the window into a wall. They cost a little bit of money. I don't think they cost as much as the window. Maybe they do. The price one, and some of them are automatic, and they are working to make it more aesthetically pleasing because people do not like the look of shutters. There are shutters from the inside. There are shutters from the outside. So if you don't want to look from the outside, you can put them on the inside. They have different options for the shutters. Weather stripping is very important because again, we're opening doors and windows. There's an area where you're always going to have to seal. You have a lot of weather stripping in your car, and the mold on your door gets old or crispy or cracked, it's going to leak some water, and it's going to let some air in and out. So this is foam. You can put foam. And you want something flexible. It can't be rigid, again, right? Because air is very thin, and it's very lightweight, and it's under a lot of pressure. So you want something that will seal properly under at least atmospheric pressure or 20 miles window. Felt, again, you want a window that sticks a lot. It's hard to open and close. So it's you have to find the balance, the optimum operation between something like movable and also seals. Plastic, the V-seal, and spring bronze. These are good to slot against the window, and you can see this part has some kind of rubbery material on. Silicon. Silicon is amazing. It has getting a lot of popularity recently because it's soft, it seals very well, and it's inexpensive, and it lasts a long time. Doors. So for solid doors, we have an R value of 2.5, and if we get the reciprocal of that, that's 7.75. So doors are not as problematic as windows, unless you make them problematic by using French doors and put glass in it. And those are very expensive. So I priced one in oak material, solid oak door. It's around $3,000. Yeah. And people put a lot of money on doors because why? Safety. What else?
First thing when they enter your house.
Yeah. It's the whole face of your house is the door. And for safety, you should put a solid door, solid iron door on your front. Yeah, but it looks really like a prison. So people try to get more, make it look more better. You can get insulated panel door for R value of 5. It's going to be 0.2 if you get the reciprocal of that, which is just a panel made out of pieces of plywood, and you fill it with insulation. And for some apartment buildings, you have that sheet metal door. It looks like it's wood, and it's filled with that insulation material. Storm doors. They reduce the air filtration and increase the R value of the wood door from 1.75 to 2.5. They are costly. In commercial buildings, it is the law. Do we have a storm door in this building? Yes, we do. Because we use it. No, for the main building. Do it. I tried to close it, but it's not. It's open down. If you notice, there is the main building door, and there's another door. It's always open. You notice that? So in the winter, what is the point of a storm door? Yeah, if you go to building 17, you have two doors, so the small areas in the middle gets cold, so you do not let all the, yeah, building 17, building 2.
It's a really good,
Yeah.
no,
It's
the
the biggest.
second tallest one.
It's when you come from the main campus, main door, it's in your right to the library. In your right to the
The
library.
one next to the library.
Yeah. But anyways, we have a storm door here. It's a double door, and the idea is to not lose a lot of the energy heating. In New York City, or like in a lot of cities, you see a lot of revolving doors, right? So the idea again is to limit the heat, the air exchange with the outside. So imagine if it's really cold outside, 0 degree outside, and inside it's around 70. And every time you open the door, there's a flood of air coming in, flood of air coming out. You don't want that. So storm doors are mandatory for commercial buildings. For residential, it's not mandatory, but it's a really good idea to leave a small area within, like, I think new structures they have at least 3 foot or 4 foot area where they leave the shoes and hang the coats. Go inside the first stage, then you go inside the house, which will save you a lot of money if you go in and out a lot.
Called
It
the
takes,
mud room.
huh?
The mud room.
Mud room?
Yeah.
Yeah, where you leave your muddy shoes and stuff, yeah. That's a very good, yeah,
So the storm door is right there.
yeah, yeah. There are 2 doors. The first door, there's another wood door in the middle. You can see it coming out. So basically, it's the second door. Huh? Yeah, after Bill's class. So the idea again is to limit the heat exchange to the outside. Door with a turbine is a little bit different than windows. And did you notice that the fridge door has a magnet in it? Some doors still have magnets on it, just to grab the door. Again, if you think of the door, it's heavier, it's bigger, it's supposed to be sturdy, you don't want to be flimsy, and you want to seal very well. So you can use a big magnet on some doors to get the door. They also have those mechanical linkage that goes to the door. And because the door is very open, it's going to lift all the cold air out, or all the cold air in. So you want to seal that very well. So in your book, if you go through the book, there is a lot of information about the windows and doors. Can I see the book? Yeah, but, so that's chapter 5. I think it covered most of the stuff that I think it's important here. Yeah. Okay. So that's what I have for you material. I'm gonna sit the last 10 minutes and I wanna check on the project. You can start. Thank you.